Good morning everyone. I am Priyanka Bhatt and topic of my presentation today is forecasting and identifying multi-technology convergence based on patent data, the case of IT and BT industries in 2020. The key concepts used in this study are technology convergence, patent citation analysis, neural network analysis, and dependency structure metrics. Technology innovation has occurred through convergences in various fields, including computers, semiconductors, mobile telecommunication, and medical healthcare fields, and the possibilities of generating future technological innovations through convergence are infinite. In this situation, understanding the state of development of technology convergence and forecasting the promising convergence areas will enable any firm to perform more effective research and development activities and supply the market with a new technology or product that reflects the needs of customers at the right moment. Pattern analysis has been used not only to monitor technologies over a short period of time, but also to analyze technology innovation patterns in order to develop a long-term technology strategy. So in this way, taking the patent as the objective and mature indicator of technological changes, patent analysis has been used as an analytical tool for technology convergence in this study. Having a new technology opportunity is a significant variable that can lead to dominance in competitive market. In that context, accurately understanding the state of development of technology convergence and forecasting promising technology convergence can determine the success of a firm. The purpose of this paper is to propose a forecasting methodology for multi-technology convergence based on a patent citation analysis, a dependency structure matrix, and a neural network analysis. The suggested methodology enables both researchers and practitioners in the convergence field to plan their technology development by forecasting the technology combination that will occur in the future. So, previous studies have mentioned technological convergence, which related to analyzing the worldwide trends in convergence in hydrogen inventions, proposing a method to analyze the technology convergence trends by measuring knowledge flows of patents, and so on. Also, measuring the degree of convergence of cross-disciplinary technologies, studying the degree of mergers and the relationship between different technology domains, analyzing the associative relationship between green technologies using patent co-classification, and both patent citation analysis and patent co-classification analysis have been used to study the technology convergence in past. The single technology and technology pair has also been studied. Patent citation analysis has been used as a main approach in technology convergence studies to identify the convergence trends, analyze the convergence evolution, trajectories, and determine the newly converged technologies. The basic concept of patent citation analysis is that there exists a technological link between patents if one patent cites another. Once that link is created, new knowledge comes from combinations of existing knowledge. So, if one patent cites another, that is, a new technology is created by combining existing technologies, this is regarded as convergence. So, patent citation matrix is an n by n structure containing the technology classes and number of citations. The technology classes in the column cite the technology classes in the row. And if T2 is cited by T3, X32 indicates the number of citations from T2 to T3. The objective of a neural network is to obtain meaningful outputs by controlling the weights on the relationships between inputs and outputs. There are various neural network techniques, including a multi-layer feed-forward neural network, recurrent neural network, time delay neural network, and among these technologies, a multi-layer feed-forward neural network trained by a BPN algorithm is most commonly used for forecasting. One major application area of neural network is forecasting multivariate nonlinear nonparametric statistics, and many studies have established that an neural network forecast is more accurate than those of other forecasting methods such as moving average, autoregressive integrated moving average, linear regression, and so on. In this research, a neural network was applied to produce expected future citation values for a citation matrix. Considering the complexity of the data and the forecasting accuracy of neural networks, it would be appropriate to apply the neural network to patent data for this study. In addition, since the purpose of this study is to produce accurate results rather than to gain implication from parameter estimation, the use of non-parametric analysis method is used. Dependency structure matrix has been studied to reduce the risk arising from product development phase, establishing DSM tools to suit the building design process and approach to managing software systems using dependencies, applications to deal with complex issues in healthcare management, financial systems, public policy, natural sciences, and social systems. So, in a nutshell, a DSM, which is also known as a design structure matrix or dependency source matrix, it is a network modeling tool that is used to represent the elements comprising a system and the interactions between the elements. It is particularly well suited for analyzing complex systems and therefore has previously been used actively in the areas of engineering management. This method is powerful, especially due to its advantages in terms of compact format, visual nature, intuitive representation, powerful analytical capacity, and flexibility. It provides a simple and concise way to represent a complex system. It is also amenable to a powerful analysis such as clustering and sequencing. A DSM is an n by n matrix that has. So this study is different from the previous existing studies in various ways. For example, the focus of this study is forecasting the future trends on convergence, whereas existing studies have always tried to identify the past trends, observing the past trends based on data and so on. Object used is modeling, visualizing, and analyzing the convergence trends, whereas in past it was only identifying the convergence between a single or a pair of technologies. So the research framework of this study follows the step 1, which is the selecting target technology fields, followed by collecting patent data from patent database. In this study, it is a USPTO, United States Trademarks and Patents Office database. After collecting the data, step 3 is to develop a citation matrix using patent citation analysis. After we create the patent citation matrix, we create a dependency structure matrix and identify key converging technologies. And finally, we forecast the future technology convergence using neural network and DSM. So, for multi-technology convergence, we select the technology field to forecast first. So for example, a technology field in which an existing IT is converged with a biological phenomenon to produce new IT products or services using biological principles and characteristics. So three types of fields are in IT and BT are identified, like mobile telecommunication, telematics, electrical computing, digital content, software solution, etc. And in BT, it's biomedical devices, molecular bioengineering, and surgery. So these are the codes for all technology fields. For example, when we extract the data from the database, every keyword or every technology field is given a particular code. So this is just a snapshot of each sub-technological fields and their codes related. So the data collected is from 1996 to 2005. The database is National Bureau of Economic Research, NBER. The data is collected from USPTO patents for IT and BT technology fields. So the information about database collected, the information about data collected is number of patent citation, the patent number of the citation, the registered date of the cited patents, and USPC, IPC, CPC codes of the patents. The information from 387,703 patents and 353,785 citations between them was used. So A forecast is made with 10 years of data. 10 patent citation metrics are constructed, which are used as inputs for neural network analysis and to investigate the past trends of convergence. So here is a snapshot of patent citation metrics for 2004. To identify the convergence areas, first a DSM sequencing algorithm was applied to the citation matrices on each of the 1996 to 2005 datasets to examine the past trends. The cutoff value was kept to the average citation frequencies for all patents published over the past 10 years, which correspond to 4134.4. The convergence trends over 10 years split into 5-year unit are presented. So a future citation matrix is developed using a neural network. So before applying the DSM to forecast citation metrics, it is worth using it on past data divided into several periods, which helps understand the past trends of convergence. To convert the citation matrix into a matrix with binary values, cutoff values are applied. A value of 1 is assigned when at least a certain amount of citation occurs within the patent citation matrix and 0 when no or fewer citation occur. So because of the characteristics of the DSM, the citation relationship between the same technologies is excluded. The first step to forecast the convergence status using the NN is defining the inputs and outputs. In general, the value of a given time t is correlated with the past values of precedent times t-1, t-2, and so on. Therefore, instead of using only a single value, the sum of past n time series data was used in this study. The number of data that shows the best performance is chosen to calculate the values for an input variable. The overall forecasting accuracy can be measured by the mean absolute percentage error with the following formula, where ET is the actual value at time period t and FT is the forecast value at period t. So accordingly, the number of datasets was set to 6. The experiment was conducted on the randomly selected variables in 2006 citation matrices. The number of citations from 365 to 235, from 435 to 424, and 705 to 379, and the real citation values were compared with the estimated results. The experiment results shown in this table revealed that we could expect the greater performance, minimum average and standard deviation values by training the neural network with the sum of the last 6 years' data as an input. So if we assume that we forecast the value of a specific year in future, for example 2006, using the data of past 10 years, that is 96 to 2005, in the neural network matrix t is 1996 and x32 value is 1997. The x32 value of 2006 that we are trying to forecast is the output value of 2005. If the value is to be forecast for 2016, the NNN training can be performed 10 more times. So to project the data for 2006, past 10-year citation data, as we mentioned before, SPSS 18 was used for this research. The dependent variable was normalized values at time t, and independent variables were normalized values at time t-1. So training dataset included the values from 96 to 2005, and test data was collected from 2006 citation matrix. The MAP value obtained from neural network was from 12.31 to 21.08%, which indicates that the forecasting performance is quite good, being greater than the performance of other growth curve models. A DSM sequencing algorithm was applied to the citation matrices on each of the 96 to 2005 datasets to examine the past trends of convergence. So therefore, the convergence trends over 10 years were split into 5-year units for ease of visualization. The cutoff value of DSM was set to the average citation frequencies of all patents published over last 10 years, which corresponded to 4134.4. So the first figure here in this slide shows a DSM built on one cluster consisting of USB-C 424, 435 and 514 during the period from 96 to 2000. This convergence cluster was formed within the same technology field, bioengineering in biotechnology. Here it should be noted that 514 is an integral part of 424 and thus it is convergence between 514, that is drug, bioeffecting and body treating compositions, and 435 molecular biology and microbiology. Nevertheless, the analysis results show that not only the convergence between two technologies but also among three technologies could be identified with the suggested approach, which is one of its advantage over other approaches. Two more convergence clusters were identified in other unit of 2001 to 2005. One of them consists of USPC 340 and 701 within IT sector, while the other consists of 707 digital contents and 715 software solutions, again in the IT sector. The analysis results uncovered that technology convergence within the same industry field was dominant by 2005. So this is the projected patent citation matrix of year 2020. Finally, we present the results of applying a DSM technique to the projected patent citation matrix of 2020, which helps identify the expected future convergence. The convergence between 340 and 701, 707 and 715, 424, 435 and 514 are seen to be dominant in 2020, whereas we also see convergence between 600 and 607 and 705, which is data processing in financial business practices, and 707, which is digital contents. So until 2020, the convergence of IT and BT fields is observable within the same fields on the assumption that the convergence defined in this study is the knowledge exchanges among technologies. Moreover, in the convergence between the two fields, it's expected that 424 and 705 will act as a knowledge provider in general, while 340 will act as a knowledge absorber. The forecasting results suggested that the number and size of convergence clusters would continue to increase over past 10 years in terms of convergence trends. We can also observe that the cluster whose number was 1 in 96 to 2000 increases to 4 in 2020. So, in terms of continuity of the convergence, each cluster appeared continuously until 2020 since they were built. Especially 424, 435 and 514 is believed to contain core technology convergence for biotechnology, regardless of the time. Through this analysis, though this analysis was restricted to the citation matrix for 2020 using data from 96 to 2005, the continued projection of forecasted results will enable us to obtain the citation matrices in the following years and identify the convergence trends in the distant future. Three types of technology convergence were identified. One was coupled, interrelated, and intermediated. Coupled is between two technologies where both knowledge inflow and outflow. Interrelated is where all technologies in the converging cluster are closely related to each other with extensive knowledge exchanges. Intermediated are where pairs of technologies are linked together through a mediation of a particular technology. So, this methodology enables a quantitative forecast of the status of future technology convergence, an attempt to overcome the limitations of an expert-based forecast method or a convergence analysis focusing on the past trends. The proposed methodology forecasted a future technology convergence from a multi-technology perspective. This proposed methodology generated convergence clusters through a DSM to enhance the visibility of convergence patterns among multiple technologies. The limitations and future scope of this study may be explained as the elaboration of neural network, which is required in order to determine the input variables or cutoff values. Instead of using a single input variable with sum of several time series values, it will be possible to adopt several input variables. Determining the cutoff values is also worth considering. Finding the most appropriate cutoff value should be addressed, and future research needs to define several types of convergence and suggest an approach suitable for each types. Thank you.